Okay, hello everyone. In this video, we are going to discuss about application of Laplace transform to solve differential equations. In our last two classes or videos, we have been discussed in detail about inverse Laplace transform using partial fraction. We have been discussed type 1, type 2, type 3 type of numericals in detail that we have been discussed in our last two classes. In this class, we are going to discuss application of Laplace transform to solve differential equations. So to solve the differential equations that may be homogeneous and non-homogeneous using Laplace transform, knowledge about Laplace transform of derivatives is essential required. So we know that Laplace transform of nth derivative of a function f n t is nothing but your s to the power n Laplace transform of f of t minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f dash 0, that means first derivative 0, so on. Last term will be f to the power n minus 1 0. Okay, these things already we have been discussed and proved itself. May you remember that Laplace transform of derivative, when we discussed at that time we proved this one. Okay, here I written s to the power n capital F of s. Capital F of s is nothing but also Laplace transform of f of t. Okay, whatever here I have been written Laplace transform f of t, or here instead of this one also we can write capital F of s. So at that time we have been proved that how the nth derivative, sorry, Laplace transform of nth derivative of a function will be this much. Okay, in detail at the time we have been discussed, but this value, that means this result is required in this topic, that means to solve the differential equations. Okay, so here if we are going to consider second derivative or f double dash t. Here nth derivative, this result for second derivative, Laplace transform of second derivative of a function f of t will be equal to, here n will be 2, so this will be 2 s to the power 2 Laplace transform f of t minus 2 minus 1 will be 1 s to the power 1 f of 0 minus s to the 2 minus 2 will be 0, that means s to the power 0 will be 1 and f dash 0. So last expression for double dash will be f dash 0, right? So if we are going to consider single derivative of a function and corresponding Laplace transform, then Laplace transform of f dash t will be, here dash 1 dash is there, means n equal to 1. So here you put n equal to 1 means s to the power 1 Laplace transform f of t minus, if I will put n over here, s to the power n 1 minus 1 0, so s to the power 0 is 1 and last term will be f of 0. Right, now if we are going to consider instead of f of t yt, then instead of f of t here we can write yt. Okay, now if we are going to consider Laplace transform of f of t or Laplace transform of yt equal to y bar, then here you can see this one, instead of Laplace transform of f double dash t, if we are going to consider instead of fy, then Laplace transform y double dash t will be equal to a square Laplace transform of yt minus s, here s y0, instead of f y we can consider considered here. Okay, so y0 minus f dash 0, here we have to write y dash 0. Here y0 means y at t equal to 0, y dash 0 means y dash at t equal to 0. So now if we are going to consider Laplace transform of yt will be equal to y bar, then here this one will be written as y bar. So a square y bar minus s y0, that means y at t equal to 0 minus y dash at t equal to 0. So any second derivative of a function and corresponding Laplace transform will be this one. Likewise, third derivative means n equal to 3. If we are going to consider the terms, we can write. Okay, now we are going to go for to find out the solution of a differential equation. Here homogeneous, because right hand side is 0, so homogeneous differential equation, this one, y double dash 2y dash plus 5y equal to 0. Initial value condition has been given, y 0 equal to 2 and y dash 0 equal to -4. Suppose here y dash given, suppose here is the differentiation with respect to t, so this will be d square y by t square, that means y double dash. So y double dash here written means d square double derivative with respect to t, suppose we have to consider, and here y 0 equal to 2 means y at t equal to 0 equal to 2, y dash at t equal to 0 equal to -4. These are the two boundary conditions or initial value conditions, we can say. Now how we are going to solve this differential equation by using Laplace transform here starts. Okay, the given question is your this one, y double dash plus 2y dash plus 5y equal to 0. Applying Laplace transform both the side of this equation, Laplace transform of this y double dash 2 into Laplace transform of y dash, here y double dash function of t I written. Okay, suppose we consider y is the function of t or differentiated with respect to t, so y double dash function of t, Laplace transform of y dash function of t, 5 into Laplace transform of y, you can write itself function of t equal to 0, right? Okay, now as we discussed that Laplace transform of double derivative of a function is your a square Laplace transform of y minus s y 0 y dash 0. Same thing we have been written over here. Laplace transform of y double dash t will be a square Laplace transform of y function of t. Here I not written again and again. This is the function of t, y function of t minus s y at t equal to 0 minus y dash at t equal to 0 plus 2 Laplace transform of first derivative of yt is your how much, this one, here it will s Laplace transform of yt minus y of y at t equal to 0, Laplace transform of s Laplace transform of y minus y at t equal to 0, plus 5 Laplace transform of y already is there, has been written equal to 0. Now we consider that Laplace transform of y equal to y bar. Okay, so for simplicity, for representation will be simple, for that only we consider Laplace transform of y equal to another symbol or representation y bar. So a square y bar, here Laplace transform of y, instead of Laplace transform of y we written as y bar minus 2s. How it is, here you can see y 0 at t equal to 0, y value already boundary conditions, in the boundary condition it has been given 2, so you just substitute 2 over here, it will be 2s, and y dash 0 value is -4, so minus and this minus will be plus 4, plus 2 into s Laplace transform of y is y bar minus y of 0 is your 2, plus 5 Laplace transform of y is your y bar equal to 0, right? Now you just multiply this one, so 2s y bar, this is a square y bar minus 2s taken this side, here plus 4, here 2 into 2 -4 is there, would be got cancel, and here y bar y bar is there, y bar taken common, and a square plus 2s plus 5 will be equal to 2s, so that implies y bar will be 2s by this much, y bar equal to 2s by a square plus 2s plus 5, that equal to 2s by this can be written as s plus 1 whole square plus 4, that means s plus 1 whole square means a square plus 2s plus 1, here 4 is there 5 and 2s, so a square plus 2s plus 5 can be written as this one, 4 can be written as 2 square. Now we are going to take the inverse Laplace transform of this equation both the side. Now apply inverse Laplace transform above equation, we get inverse Laplace transform applied over this. See, this is nothing but your Laplace transform of y. If I will apply again inverse Laplace transform, then Laplace inverse Laplace will be got cancel, like 1 by x into x will got cancel. Similar way, already inverse Laplace transform, sorry, inverse Laplace transform of y means y bar is there. If I will apply inverse Laplace transform on uh, that, or we can, if we are going to operate inverse Laplace transform over this, then we can found only y. Okay, so Laplace transform of this one, inverse Laplace transform of this one. So here two constant taken outside, inverse Laplace transform of s by s plus 1 whole square plus 2 square. So here, to apply the cos 2t formula, so here just numerator has been modified, that the numerator has been written s plus 1 minus 1. So s plus 1 minus 1, here the numerator can be written as s plus 1 minus 1, right? So minus 1 plus 1 got cancelled, so s will be there. So this s plus 1 divided by this much we can write, minus 1 divided by this much also we can write. So here you can see s plus 1 by s plus 1 whole square plus 2 square. If we have s by s square plus 2 square, then that value will be the inverse Laplace transform of s by a square plus a square is nothing but your cos 80. That already we have been studied many times, also we have been discussed. Cos s by a square plus a square, s by a square plus a square, inverse Laplace transform is your cos 80. But if we are going to consider this one, see, s minus a by s minus a whole square minus b square, this will be e to the power 80 into cos hbt. But if we are going to consider this one, s minus a by s minus a whole square plus omega square will be e to the 80 into cos omega t. You just compare this one, cos 80 is there and here cos omega t. That means here s a square, but here s minus a square. Then e to the 80 will be come up and cos omega 2 will be come up multiplied with that. So here, if we have suppose s by a square plus 2 square, then the answer will be cos 2t. But as it is another one is added with s, so this can be written as s minus of minus 1. So only for that e to the power minus t will be multiplied with cos 2t. These things we have been discussed several times. This is nothing but your fast shifting theorem. Fast shifting theorem, by using fast shifting theorem. So by using fast shifting theorem, s plus 1 by s plus 1 whole square plus 2 square will be equal to e to the power minus t cos 2t. So here you can see 1 by s plus 1 square plus 2 square. What we done, 2 multiplied and 2 divided, 1 by 2, 2 by 2 s plus 1 whole square plus 2 square. So if we have 2 by a square plus 2 square, 2 by only a square plus 2 square, the answer will be sin 2t. But as it is s plus 1 is there, that means s minus of minus 1 we have to consider, and we are going to apply the fast shifting theorem, and we are going to get the answer is your e to the minus t into sin 2t. Here I clearly written that by using fast shifting theorem, that inverse Laplace transform of f of s minus a will be e to the 80 f of s. Okay, e to the e to the power mistake I written, e to the 80 f of t, e to the 80 f of t. Okay, f of t. So here sin 2t e to the 80 multiplied, cos 2t e to the 80 multiplied, right? Okay. So finally we got, if I am going to take e to the minus t outside, then it will be e to the this is 2 cos 2t, and here 2 multiplied, 2 to got cancelled, sin 2t is your answer. Now we are going to go for another question, that is your y double dash plus y equal to 2 e to the t. This is a non-homogeneous differential equation because right hand side some factor is there, and initial value condition is there given that y0 means y at t equal to 0 equal to 0, y dash at t equal to 0 equal to 2. These are the two boundary conditions, or you can say initial value conditions has been given. Now we are going to solve this differential equation by using Laplace transform. So given differential equation is y double dash plus y equal to 2 e to the t, and this y is the function of t. Take Laplace transform both the side. Laplace transform of y double dash, which is the function of t, plus y plus Laplace transform of y, which is the function of t, equal to 2 constant Laplace transform of e to the t. Here I written clearly y is the function of t. So as we discussed that Laplace transform of double dash, double derivative of a function y, which is the function of t, will be equal to a square into Laplace transform of y, which is the function of t, minus s into y at t equal to 0 minus y dash at t equal to 0, plus Laplace transform of y t already is there written over here, equal to 2 into Laplace transform of e to the t. We know that 1 by s minus a. Here a is your 1, so s minus 1. Now we have to just put Laplace transform of yt equal to y bar, and we have to use the initial value condition at the meantime. So here a square, this one will be y bar, minus y of 0 is given 0, so this term will be 0. Y dash 0 is given 2, so minus 2 plus y bar equal to 2 by s minus 1. So here y bar is there, taken common, a square plus 1 equal to this 2 is taken this side, so 2 by s minus 1 plus 2, just simplified we found 2s by s minus 1, and that implies s y bar we found 2s by s minus 1 only there into a square plus 1. Let this is your equation number 1. Now consider partial fraction of RHS of equation number 1. To solve this one, what we have to do? We have to apply the partial fraction. So here you can see this is a linear factor and this is a quadratic factor and not repeated itself. So 2s by s minus 1 into a square plus 1 will be written as a by s minus 1, because as this is a linear factor, so we have to write a by s minus 1, but this is a quadratic, a square is there, a square plus 1, so for this we have to write plus bs plus c by a square plus 1. Now if I am going to add these two terms, we found a square plus 1 plus bs plus c into s minus 1. So here this denominator and denominator are same, so obviously numerators also will be equal. So 2s will be equal to a into a square plus 1 plus bs plus c into s minus 1. Just multiplied a square plus a plus bs square minus bs plus cs minus c. So if we are going to write with the coefficient of a square, s and s to the power 0, see here a minus c is a constant, or we can say this is the coefficient of s to the power 0, because s to the power 0 is your 1. So here a square, so if I will take common a square, this will be a plus b, and here cs bs, this will be c minus b into s plus a minus c into s to the power 0. So now equating, if this left hand side equal to right hand side, then obviously the power coefficient of s to the power 2, s to the power 1, s to the power 0 will be separately equal. So here coefficient of a square is your a plus b, but this side there is no a square term is there, so a plus b will be 0. Okay, here I written a plus b equal to 0, so hence a equal to minus b. Now here you can see this is s and its coefficient is 2, and here s coefficient is c minus b. So c minus b will be 2 and a minus c will be 0, because there is no s constant term in your left side. Okay, so a minus c will be 0, c minus b will be 2. So c minus b will be 2 and a minus c will be equal to 0, right? So here if I am going to consider instead of a equal to minus b, so this will be minus b, minus c will be 0, and just add this one with this minus b minus c equal to 0, c minus b equal to 2, so minus 2b equal to 2, b equal to minus 1. So if I will put minus 1 over here, then c will be equal to minus over here means it will be plus 1, c plus 1 equal to 2, c will be equal to 1. So a we got 1. So here if b equal to minus 1, so obviously a will be 1. So A1, C1, B minus 1 we found. Now we are going to put these values in your equation number 2. In equation number 2, what we are going to found is here, see, this one is nothing but your y bar. Okay, and this is your equation number 2, and equation number 1, if I am going to consider, this value is nothing but y bar, or y bar equal to this one. We can consider same thing I haven't written. Now equation number 1 will be by considering equation number 2. Y bar will be equal to a means 1 by s minus 1 plus bs plus c. Here b is your minus 1, so c is your 1. So obviously this will be 1 minus s by s square plus 1. So we found y bar equal to 1 by s minus 1 plus here 1 by s square plus 1 minus s by s square plus 1. Now we are going to take the inverse Laplace transform, because our requirement is the to finding the y, or the solution of the differential equation means we have to find out the y. So if we are going to take the inverse Laplace transform both the side, then inverse Laplace transform y bar will be y, and inverse Laplace transform of 1 by s minus 1 will be equal to e to the t. Inverse Laplace transform of 1 by a square plus 1 square, sorry, 1 by a square plus 1 square will be equal to sine t, because we know that a by a square plus a square is your sine at. Sorry, here a is your 1, so it will be sine t. And we know that s by a square plus a square is nothing but cos at, and here a is 1, so cos at. This is your answer. Now we are going to go for the another question, that is your, this is also a non-homogeneous differential equation, that is your d square x by dt square plus 9x equal to cos 2t, and given that x equal to x at t equal to 0 will be equal to 1, x at t equal to pi by 2 equal to minus 1. These are the two boundary conditions or initial value conditions that we have to use to solve this differential equation, or to find out the x value for this differential equation using Laplace transform. Okay, so let's start. Given differential equation is your d square x by dt square plus 9x equal to cos 2t, or we can write x double dash plus 9x equal to cos 2t. Here x is the function of t. Now we are going to take the Laplace transform both the side. Laplace transform of x double dash plus 9, Laplace transform of x equal Laplace transform of cos 2t. So here double dash is there, means a square into Laplace transform of x function of t minus s x at t equal to 0 minus x dash at t equal to 0 plus 9 Laplace transform of x, and Laplace transform of cos 2t will be equal to s by 2 square plus a square plus 2 square. So here we have to just put, here I am going to write, we have to put Laplace transform of x, or x function of t is your x bar. So this will be x a square x bar, s square x bar minus x0. Here x0 is given x0 is given 1, so instead of x0 we have to put 1. Okay, 1 into s minus x dash 0 will be remaining there, plus 9 into Laplace transform of x, that means x bar equal to s by a square plus 2 square. Here we put substituted x bar instead of Laplace transform of x. So here you can see that what we done here, we considered x dash 0 is an unknown constant, let that is your alpha, and taken this side, this minus s also taken this side, and left hand side we found a square plus 9 into x bar equal to this x dash 0 considered as alpha, taken this side alpha, plus this s taken this side plus s by a square plus 2 square. So here x bar will be equal to alpha by a square plus 9 plus s by a square plus 9 plus s by a square plus 9. Already already is there, a square plus 2 square, a square plus 2 square, let this is your equation number 1. Now we are going to go for the partial fraction uh, of third term, because there is no required of the partial fraction of this one, but here partial fraction is required because two terms, this one a square plus 9, a square plus 2 square, both are quadratic equations. So here this one needs partial fraction. So partial fraction third term we are going to do. So here I written, now consider the partial fraction of third term of LHS of equation number 1. S by a square plus 9 into a square plus 2 square will be equal to, here quadratic means as plus b by a square plus 9 plus cs plus d by a square plus 2 square or 4. I just added these two and we found this one. So here if denominator will be equal, then the numerator s will be equal to this much. Here I multiplied with all the terms. I, I found this one. You can check uh, by doing in your rough. So what we found, a sq plus 4as plus b a square plus 4b plus c sq plus 9 cs plus d a square plus 9d, and here we have been written the systematically that a plus c is the coefficient of asq. Here you can see asq, here csq, taken csq common, so we can found a plus c, and a square is there, a square, so b plus d a square, 4a plus 9cs plus 4b plus 9d is the constant. That means this is the coefficient of asq, a square, coefficient of s, and this is the coefficient of s to the power 0, because s to the power 0 is your 1. So if this equal to this, that means coefficient of all the s powers will be, has to be equal. So equating the coefficient of a square, sq, a square, s to the power 1, s to the power 0 of LHS and RHS, we get what, here sq is there, coefficient a plus c, but this side there is no sq term is there, so a plus c will be equal to 0, a equal to minus c. Okay, this side s square is term is not there, but so b plus d will be equal to 0, b equal to minus d. Okay, but here s term is there and the coefficient is your 1, so 4a plus 9c, 4a plus 9c will be 1, but there is no constant term you can found in the LSS side. So 4b plus 9d, 4b plus 9d will be equal to 0. Just I simplified these equations and I found, you can check in your rough, a equal to minus 1 by 5, b equal to 0, c equal to 1 by 5, d equal to 0. See here d we found 0, so b equal to minus d means 0. So obviously like this a value, here we can put minus c, and we solved. A found minus 1 by 5, b 0, d 0, c equal to 1 by 5. We substituted this a b c d value in equation number 1. In equation number 1, what we found, x bar alpha by a square plus 9 plus s by a square plus 9, or 3 square plus, here this one is nothing but these two terms by substituting a b c d value. So here a equal to minus 1 by 5, where b equal to 0, so minus 1 by 5 into 1 by a square, minus 1 by 5 into s by, sorry, here s is there, no, s by s square plus 3 square, then cs plus d, here d is 0 and c is your minus 1 by 1 by 5, so 1 by 5 into 5, this one is your 5 by a square plus 2 square. Okay, a square plus 2 square, because a square plus 4 is there, so a square plus 2 square. Now we found alpha into 1 by a square plus 3 square plus, here you can see s by a square plus 3 square, that means 1 minus 1 by 5, 1 minus 1 by 5 is your 4 by 5. See here these two terms are same, but the coefficient here is 1, this is your minus 1 by 5. If we will add it, then we can get 4 by 5, and this is your 1 by 5, s by a square plus 2 square, let this is your equation number 2. Now we are going to take the inverse Laplace transform of equation number 2. What we are going to get, inverse Laplace transform of left hand side, this is the x bar, alpha is constant taken outside, inverse Laplace transform of 1 by a square plus 3 square, 4 by 5, Laplace transform, inverse Laplace transform of s by a square plus 3 square, 1 by 5, into inverse Laplace transform of s by a square plus 2 square. So this one will be x equal to, here you can see a square plus a square is there. A means 3, so here I multiplied 1 3, divided 1 3, 3 by a square plus 3 square plus 4 into, this is this is straightforward is there, straightforward, that means a square by a square, s by a square plus 3 square, that means cos 80 cos 3t, and this is your also cos 2t. So this value a by a square plus a square, a cube mistake I written, this is your 3 square, 3 square means 3 square. Okay, so this will be sin 3t. So x equal to alpha by 3 sin 3t plus 4 by 5 cos 3t plus 1 by 5 cos 2t. Let this is your equation number 2. To find the unknown variable, alpha value we substituted as unknown. To find alpha we have to consider boundary condition, which is given that x pi by 2 equal to -1. So this value will be -1 when we are going to consider at t equal to pi by 2 for this equation number 3. Okay, so -1, that means x will be -1 alpha by 3 into sine, here t will be pi by 2, means 3 pi by 2 plus 4 by 5 cos 3 into pi by 2 plus 1 by 5 cos 2 into pi by 2 means pi. Okay, so -1 will be equal to minus, here you can 3 pi by 2 is nothing but -1, so minus alpha by 3, and cos 3 pi, any pi by 2, n pi by 2 cos will be 0, this term is cancelled out, and here we found this value will be, cos pi is -1, so minus 1 by 5, right? So hence we found alpha equal to 4 into 3 by 5, or alpha we found that this is this one. So if I will put this alpha 4 into 3 by 5 here, so 3 3 got cancelled, and we found 4 by 5 sin 3t. Okay, plus 4 by 5 cos 3t plus 1 by 5 cos 2t is your answer. Okay, now we are going to go for another question, that is your solve the non-homogeneous differential equation, this one, d square y by dt square plus 2 dy by dt plus 5y equal to e to the power minus t into sin t, where initial value condition given as y at t equal to 0 is your 0, y dash at t equal to 0 equal to 1. Okay, so start to solve. Given that this equation written, so here double derivative also can be written as y double dash plus 2 y dash plus 5 y equal to e to the minus t sin t. Here y is the function of t. Take the Laplace transform of the above equation. We found Laplace transform of y double dash plus 2 into Laplace transform of y dash plus 5 into Laplace transform of y equal to, these y whatever written over here are the function of t. Okay, Laplace transform of e to the power minus t into sin t. So here Laplace transform of y double dash, which is the function of t, here also function of t, here also function of t. So this double derivative and corresponding Laplace transform, we know that a square Laplace transform of yt minus s y at t equal 0 minus y dash at t equal 0. Then Laplace transform of single derivative of y or yt, 2 into s into Laplace transform of y, which is the function of t, minus y at t equal 0 plus 5 Laplace transform y already there has been written, and e to the minus t sin t by considering fast shifting theorem. See, if we have only sin t, the answer will be 1 by a square plus 1, but as it is e to the minus at is there, so here instead of s we have to write s of s minus a. So here a is your -1, so s minus of -1 will be +1, s plus 1 whole square plus 1. This is nothing but our fast shifting theorem. By using fast shifting theorem, this one will be the answer of this one, Laplace transform e to the minus t into sin t. Now we have to just put Laplace transform of yt equal to y bar in the above equation what we found, and corresponding given at the meantime we have to also put the initial value conditions in the above equation. So a square, this one will be y bar, and s minus s y0 has been given is your 0 0, and here y dash 0 is your 1, so y dash 0 equal to 1 plus 2 into s y bar, y0 is given 0, cancelled out, plus 5 into y bar. Laplace transform of yt is your y bar equal to this much. Okay, so here -1 taken this side, and here y bar taken common, a square plus 2s plus 5 equal to this one taken this side, so 1 plus this one, and with simplification we found this one, a square plus 2s plus 2 plus 1 divided by this one. So y bar will be how much? The numerator will be 2 plus 1 equal to 3, the a square plus 2s plus 3 whole divided by this term into this term. Okay, this term will be multiplied with this term, a square plus 2s plus 5. Now we are going to consider partial fraction. Okay, at the time of starting to discuss partial fraction, may you remember type of partial fraction. This example I considered inverse Laplace transform using partial fraction. At that time I considered this differential equation what we are discussing now. Okay, so this is nothing but your y bar equal to here you can see there is no repeated quadratic function, so as plus b by this one plus cs plus d by this one. Let this is your equation number 2. Now we have to add these two terms, so this a square plus 2s plus 5 multiplied with this one, cs plus d will be multiplied with this one divided by this into this, so denominator will be same means numerator will be same, so a square plus 2s plus 3 will be the numerator what we discussed. So this one divided by this one, as the denominator will be same, I repeatedly I am not written over here. So if denominator will be same, the numerator will be same. Numerator is your a square plus 2s plus 3. It will better. Okay, leave it. So numerator here it is written. So a square plus 2s plus 3 will be equal to this one. So here I multiplied as plus a square, as cube, as plus 2s, 2a square, as plus 5, as plus 5 plus 5as. Here b into a square, b 2s, b 2bs, like this. All the terms I multiplied and I written here. So if I am going to write collectively all the powers, s powers and corresponding coefficient, here we can see that a s cube and here c s cube. So s cube taken common, a plus c, like that a square. If I will consider all the coefficients of a square and going to write at a collectively, so here 2a and b, here d is there, here 2c is there, so a square. So these are the coefficients of s collectively written over here, and this is the constant. That means this is the coefficient of s cube, s square coefficient, s coefficient, that means s to the power 1 coefficient, and this is your coefficient of s to the power 0 or constant we can say. Now as we haven't discussed that if denominator of this one and this one will be same, that means numerator has to be same, and the coefficients, if numerator will be same, that means the coefficient of s powers has to same. So now equating the coefficients of s cube, s square, s to the power 1, s to the power 0 for LHS and RHS, we get here a plus c will be 0 because here s cube is there, but this side s cube term is not there, so a plus c will be equal to 0. S square coefficient 1, so this one will be equal to 1. S coefficient 2, so this much will be equal to 2. So this coefficient is your coefficient of s, and this is your 2 is your coefficient of s, so 2 will be equal to this much, and here constant equal to 3, so here I solved and I found a equal to 0, c equal to 0, b equal to 1 by 3, d equal to 2 by 3. Simple simplification. So here you can see a equal to minus c, a plus c is 0 means a equal to minus c. I just substituted, instead of a it will be minus c, means minus 2c, and b plus d plus 2c equal to 1, 2c cancelled out, b plus d equal to 1. Here a, if we are going to consider minus c, it will be minus 5c plus 2b plus 2c plus 2d equal to 2. This will be minus 3c plus 2 into b plus d equal to 2. b plus d we found 1, so like here we found minus 3c plus 2 equal to 2, that means minus 3c equal to 0, c equal to 0. So c equal to 0 means also a equal to 0. Now here you can see that 5b plus 2d equal to 3, and here this equation I have been considered and multiplied 5. 5b plus 5d equal to 5. So just subtract these two equations, we found minus 3d equal to minus 2 and d equal to 2 by 3. So if d equal to 2 by 3, here I substituted over here b plus d, and d equal to 2 by 3, b will be equal to 1 by 3. So here a 0, c 0, b 1 by 3, d 1 2 by 3 are substituted in equation number 2, and we found equation number 2 is this one. Equation number 2 we found here a 0, c also 0. Okay, so b is 1 by 3, so 1 by 3 into 1 by a square plus 2s plus 2 plus d is your 2 by 3 into 1 by a square plus 2s plus 5. Let this is your equation number 3. Now applying inverse Laplace transform both the side. See, this value is nothing but y bar. Okay, y bar equal to this much. Okay, y bar equal to this much. Y bar equal to this much, and this much value is nothing but this side. Okay, inverse Laplace transform applied both this side of this equation number 3, we get inverse Laplace transform of this one, or you can say inverse Laplace transform of y bar will be y. At last I have been written, so do not be worried about that. Inverse Laplace transform of this one, 1 by 3 inverse Laplace transform of this one, 2 by 3 inverse Laplace transform of this one. 1 by 3 inverse Laplace transform of a square plus 2s plus 2 can be written as s plus 2 whole s plus 1 whole square plus 1 square. 1 by 3 inverse Laplace transform a square plus 2s plus 5 can be written as s plus 1 square plus 2 square. Okay, so here you can see that 1 by s minus of minus 1 square plus 1 square, that means sine t into e to the minus t. Here 2 by 2 square means sine 2t into e to the minus t by fast shifting theorem. Okay, so this is straightforward answer. So it will be 1 by 3 into e to the minus t into sine t plus 1 by 3 e to the minus t into sine 2t by using fast shifting theorem. I have to write over here by using fast shifting theorem or property. Fast shifting theorem or property, because as we know that already we discussed several times, that if we have here you can see, if we have a by s, a square plus a square, this is sine t. But if we have omega by s minus a whole square plus omega square like this, by shifting theorem, this will be e to the negative into sine omega t. So here this is nothing but s minus of minus 1 square, and this one also s minus of minus 1 square plus 1 square. So here by using fast shifting theorem, it will be e to the minus t sine t, e to the minus t sine 2t. Taking common 1 by 3 to the minus t, we found sine t into sine t plus sine 2t. And as I told that this value is nothing but y bar. So inverse Laplace transform y bar will be equal to y equal to this much. Okay, so we found the solution is equal to this much is your answer. Now we are going to go for another question, that is this is your third order differential equation. dqy by dtq plus 2 d square y by dt square minus dy by dt minus 2y equal to 0, and in this initial value condition has been given is your y at t equal to 0 1, dy by dt equal to 2 at t equal to 0, d square y by dt square equal to 2 at t equal to 0. These are the initial value condition or boundary condition given, and this is the differential equation what we have to solve using Laplace transform. The given differential equation is this one, or this third order differential equation, that means dqy can be written as y triple dash t plus 2 y double dash t minus y dash t minus 2y equal to 0, where y is the function of t. Here y function of t written, function of t, function of t, function of t. Now we are going to apply the Laplace transform both the side. Laplace transform applied over this one, Laplace transform of y triple dash t to y double dash t minus Laplace transform y dash t minus 2 into Laplace transform of y t equal to 0. Already we have been discussed that nth Laplace transform of nth derivative is your this one is your this one. If n equal to 3 for 2 8 up to this question we have been considered the double derivative only, but as it is third order, so here you can see that if we are going to consider 3, so this will be sq Laplace transform of f of t, whatever written sq Laplace transform of yt. Okay, and this will be s to the 3 minus 1 means s to the power 2 f of 0, s to the power 2, here y instead of f y is there, so y 0, and then s to the power n minus 2, that means 3 minus 2 1, so s to the power 1 y dash 0, here you can see y dash 0. Next term will be how much? Next term will be minus s to the power n minus 3 f double dash 0. Okay, so if this one 3 then 3 minus 3 will be 0, so s to the power 0 will be 1 and f double dash 0 or y double dash 0. Then this one Laplace transform of double derivative of y is your a square Laplace transform of y minus s y at t equal 0 minus y dash at t equal 0, and single derivative will be minus s, minus is the s into Laplace transform of y, which is the function of t, minus y at t equal to 0 minus 2 Laplace transform of y, which is the function of t equal to 0. Now we have to put Laplace transform of yt equal to y bar, and boundary conditions also we are going to use. At the meantime, the above equation, that means this equation will be, here you can see that this one will be y bar, so sq y bar minus s square, because y0 given as 1, so it will be s square, then y dash 0, y dash 0 means dy by dt at t equal to 0 is your 2, so here y dash 0 means 2, so it will be minus 2s, and y double dash 0 also given as 2. Okay, so it will be minus 2. Here we have to put, here y double dash 0 will be minus 2. Okay, so here you can see a square, this value is your y bar, so 2 into a square y bar. Okay, then y0 given as 1, so 2 into s, 2s minus is there, then this y dash 0 is given as y dash 0 is given as 2, this one y dash 0 is given as 2, y dash 0 is given as 2, so 2 into 2 minus 4, and this one is your s y bar Laplace transform y bar, and this one y0 is given 1 minus plus 1 and minus 2 y bar equal to 0. Now collectively I written y bar terms, y bar taken common, and this will be sq 2a square minus s minus 2, and other terms taken out right hand side. So that means this one minus 2s 4s taken, minus 4s taken this side, plus 4s, this is minus 4 minus 4 minus 2 plus 1, that means minus 5 taken this side, plus 5, and this minus a square taken this side, plus a square, plus 4s plus 5. That implies y bar will be this one a square plus 4s plus 5 divided by this one s cube plus 2 s square minus s minus 2. Let this is your equation number 1. Now consider partial fraction of RHS. This one, before partial fraction we have to just rewrite the denominator, that here I taken a square common from these two terms, this will be s plus 2, minus 1 taken from these two terms, it will be s plus 2, then s plus 2 taken from these two terms, it will be a square minus 1 into s plus 2. So now this one is going to go for the partial fraction, Here this will be partial fraction. See here, s square minus 1 can be written as a square minus 1 s plus 1, s minus 1 s plus 1, because a square minus b square form is there. S minus 1 s plus 1 and s plus 2. Now this one is going to go for the partial fraction by using rule 2. Rule 2 means non-repeated quadratic equation, non-repeated linear factors, non-repeated linear factors. Okay, this one. No, non-repeated linear factor is 1. Mistakenly I written. For the rule 1, non-repeated linear factors. So this is non-repeated. S minus 1, s plus 1, s plus 2 are non-repeated, non-quadratic terms. So by using rule 1, it will be this one. This one will be written as a by s minus 1, b by s plus 1, c by s plus 2. Just add it. We can found s minus 1, s plus 1, s plus 2, and the numerator will be a into s plus 1 s plus 2 plus b into s minus 1 s plus 2 plus c into s minus 1 s plus 1. Simple. So denominator will be equal to denominator, so has to be numerator has to be equal to numerator. So this equal to this. Here here we found this one. Okay, and here you can see a square b a square plus c a square. So collectively a square coefficient will be a plus b plus c, and s coefficient will be 3a plus b, and here 2a minus 2b minus c is there, is this one. So if LH, this term will be equal to this term, that means the coefficient of a square s to the power 1 and this is your s to the power 0 means 1. That means constant will be equal to constant. Coefficient of s, this one will be equal to 4. Coefficient of a square, that means a plus b plus c will be equal to 1, because 1 is the coefficient of a square. Same thing here it has been written. Now equating the coefficients of a square, s to the power 1 and s to the power 0 of LHS and RHS, we get a plus b plus c equal to 1, 3a plus b equal to 4, and 2a minus 2b minus c equal to 5. Okay, now here 3a plus b equal to 4 is going to be subtract from this one. Here you can see b got cancelled, so minus 3a a, so minus 2a plus c equal to minus 3, right? Okay, now here you can see 2a minus 2b minus equal 5. So 2a plus 2b, here I just multiplied this one with 2, and here you can see 2a plus 2b plus 2c equal to 2. Just add it, and 2b got cancelled, 4a plus c equal to 7. And here this equation multiplied with 2 and added with this equation. Multiplied with 2 means 4a plus 4c, sorry 2c equal to minus 6. Just add this 4a minus 4a got cancelled, this will 3c equal to 1, c equal to 1 by 3, c equal to 1 by 3. We found here c equal to 1 by 3. Now if c equal to 1 by 3, if I will put over here, then we can find a equal to 5 by 3. Now use this one, this equation, a equal to 5 by 3, b plus c equal to 1 by 3 equal to 1, so b equal to minus 1. So b minus 1, a 5 by 3, c 1 by 3 substituted in the equation number 2, we can found y bar 2 means this one. This equation, a we have to put 5 by 3, 1 by s minus 1, and b equal to minus 1. So minus of 1 by s plus 1 plus c equal to 1 by 3 into 1 by s plus 2, right? So now take the inverse Laplace transform of above equation. Inverse Laplace transform of y bar equal to inverse Laplace transform of this one, and this one. So 1 by s minus a is nothing but inverse Laplace transform of 1 by s minus a equal to e to the t minus 1 e s plus 1 means s of minus 1, so e to the minus t. 1 by 3 is there, So s here 1 by s plus 2 means s minus of minus 2. So e to the minus 2t. So finally we found y equal to 1 by 3 taken common from these two terms, 5 into e to the t plus 2 into e to the minus 2t in minus e to the minus t is your answer. Okay. Next we are going to go for another question, another different style also. Y dash plus 2x equal to sine 2t, x dash minus 2y equal to cos 2t, where boundary value conditions are given, or initial value conditions are given as x equal to 1 at t equal to 0, y equal to 0 at t equal to 0. So here given y dash plus 2x equal to sine 2t, take the Laplace transform both the side, Laplace transform y dash 2, Laplace transform x, Laplace transform sine 2t Laplace transform, we know that 2 by a square plus 2 square. Then Laplace transform y dash will be s into Laplace transform yt minus y0 plus 2 into Laplace transform of x, and we have to just put Laplace transform yt as y bar and Laplace transform x as x bar. Okay, so this will be s y bar plus 2 y2, because y of 0 at t equal to 0, uh, t equal to 0, y equal to 0. So here this y0 value will be 0, and here 2 into Laplace transform of x equal x bar, 2x bar equal to 2 by a square plus 2 square, a square plus 2 square equal to 1. And again if we are going to consider this one, x dash minus 2y equal to cos 2t, then considering Laplace transform both the side, uh, Laplace transform this one and this one, Laplace transform x dash is your s x bar, because we considered as Laplace transform x equal to x bar. Okay, minus x at t equal to 0 minus 2 into Laplace transform y is nothing but y bar equal to cos 2t Laplace transform s by a square plus 2 square. So here s x bar and x0 value, x at t equal to 0 value is 1. Okay, so this value will be 1, minus 1 will be there, then this is your minus 2y bar, and this minus 1 taken this side, so this will be plus 1 plus s by a square plus 4. So one step I not written over here, so this minus at a time I taken this side, let this is your equation number 2 and this is your equation number 1, right? Okay, now consider 2 into equation number 2, s into equation number, so 2 into equation number 1, s into equation number 2, and add them, we get, carefully you have to observe, 2 multiplied with equation number 1. So it will 2s y bar plus 4x bar into 4 by a square plus 2 square. Okay, a square plus 2 square, or a square plus 4, and then s multiplied with equation number 2, s multiplied with equation number, this will s a square x bar minus 2s y bar. See, when 2 multiplied, this will 2s y bar, when s multiplied minus 2s y bar, so these two terms will be cancelled out. Then 2 multiplied with this one, this will 2 plus 2s by a square plus 4, and then we are going to add. So here I written clearly 2s plus y, when we are going to multiply 2 with equation number 1, these things we are going to get 2s y bar plus y 4x bar equal to 4 by a square plus 4, s multiplied with equation number 2, we found this one. And whenever we are going to add this term will be cancelled out, and here we can found x bar taken common will be a square plus 4, a square plus 4 equal to uh, 4 by a square plus 4, this is a square by a square plus 4. I'm adding, no, so this term plus this term plus this term, okay, is equal to, here you can see, if I'm going to add these two terms, see, this term and this term, so denominator is a square plus 4, so numerator will be a square plus 4, got cancelled, a square plus 4 by a square plus 4 plus s, so 1 plus s we are going to get. Here x bar into s plus 4, we found 1 plus s, x bar will be 1 by s plus 4 plus s by s square plus 4, s by s square plus 4, take the inverse Laplace transform, inverse Laplace transform of x bar, inverse Laplace transform of this one and this one. So this one, to convert to the sign, so sign format. So here a square plus a square means 2 square is there. So for that I multiplied 2 divided to 2 by a square plus 2 square, and here s is already there, s by a square plus 2 square. So this value will be cos 2t, and this value will be sin 2t. 1 by 2 is there, 1 by 2. So x equal to this much we found. Similarly, using equation number 1 and 2 we can get, that means if we are going to consider here we multiply 2 with equation number 1 and s with equation number 2 and add it together. Now if we are going to consider 2 is going to multiply with equation number 2 and s is going to multiply with equation number 1 and subtract both, then we can found y bar equal to a square plus 2 square equal to minus 2. So here I written similarly using equation number 2, using equation number 1 and 2. That means just we have to alter the operation what we did here, that here 2 multiplied equation number 1, s multiplied with equation number 2 and added, but I just altered that s multiplied with equation number 1 and 2 multiplied with equation number 2 and subtract, then we can found y bar into a square plus 2 square equal to minus 2. You can check your rough, okay. Then y bar will be equal to minus 2 by a square plus 2 square. Take the inverse Laplace transform both the side, and we can find y equal to minus sine 2t. So here we have been completed our uh, solving the differential equation, both homogeneous and non-homogeneous, with different styles of differential equations. Even if third order differential equation we have been solved by using Laplace transform, which is most essential or important for your exam point of view, of only asking 6 marks directly. So thank you so much for watching this video. In our next class we are going to discuss applications of Laplace transform on electric circuits, RL circuit, then we are going to discuss RC circuit, then LCR circuit. Okay, so thank you so much for watching this video. Thank you.